Hi everyone, here we've got results of our recent development project, and we can now present two different high pressure compressors that we will be offering to our customers. First we'll be talking about this large unit, which is a two-stage reciprocating compressor driven by a 2.2 kilowatt or 3 horsepower motor. It generates pressure up to 300 bar or 4,500 psi at a rate of 25 liters per minute, which is roughly 0.9 cubic feet. That compressor features dual cooling system with air cooling for the first stage and independent auxiliary liquid cooling for the second stage. This allows to keep the working temperature of the second stage piston below 50 degrees Celsius or 122 degrees Fahrenheit. Here we've got the control panel, where we have the main switch that powers up the auxiliary liquid cooling system. Right now it's on. I shut it off. You can hear that the liquid cooling system is off. Now it started. Okay, then we have the thermal circuit breaker, compressor start button, the main plug, adjustable pressure switch where you can dial the desired pressure, and machine hour meter. All these features come standard. Another notable feature of that compressor is our proprietary high pressure moisture filter. This unit is fully self-contained and does not require servicing if used to produce air rifle grade air, which can also be used for paintball. It's not breathing air, it's just air for air rifles, paintballs, or maybe for testing high pressure equipment, nothing else. Our proprietary design of the filter removes over 90% of moisture that is contained in air in terms of in form of vapor. And that moisture would otherwise turn into dew once pressurized in your tank or air rifle reservoir. Obviously, once it turns into form of dew, it's gonna cause corrosion and will eventually ruin your rifle. Now, here a couple of words about the safety features of this unit. We've got dual safety, and the first part of it is a 10 amp thermal circuit breaker, which will shut off the system if the motor is driven at the extreme rates. And the second one is a 320 bar or 5000 psi rupture disc. Whilst all the individual components of our compressors would have working pressure well over 300 bar or 4,500 psi, I would like to stress that the overall compressor has working pressure of 300 bars only. It should not be driven over that pressure. It should not be used to generate some extreme pressure, and if rupture discs break, they should be replaced with 5000 psi rated rupture disc. You should not put 7,500 psi or anything funny. Standard 5000 psi. This particular compressor, unlike some Chinese versions like Omega Raptor, use standard paintball rupture disc like this. It can be obtained from pretty much any reputable paintball supplier. What shall we do now is show that compressor in operation. I've got here a 7-liter dive tank. It's a 300 bar tank, but I'll be filling it to 240 bars because that's about a pressure that you would use for an average alloy tank. And you can see that this tank is empty. Now it's fully open, nothing whistles, siphons or whatsoever. And yeah, it's a 7-liter tank, which is equivalent to about 60 cubic feet, and we'll see how long it's gonna take. Now, before I hook everything up, there's something I would like to draw your attention to. Over here I've got a hydrometer that shows 25.1 degrees centigrade with 54% relative humidity. In such environment we should have around 11 to 12 mil of moisture in form of vapor in 1 cubic meter of uncompressed air. That should translate into between 18 and 20 mils of total moisture content in 7 liters of uncompressed air once it's compressed to 240 bars. Or it would be probably 0.6 fluid ounces. Here I've got my measuring cap with a mark just under 20 mil, so we could test how close we can get to drying that air completely. So I will hook up the tank. Next, we make sure that the pressure is correctly dialed. You can see this is the control arm and it's sitting at 240 bars. And what we shall do is start it. Before that, we would want to check on our meter. I can see that it shows 24.8 machine hours. Okay. So let's see how quickly we'll fill up the tank. As you can see, once the pressure reached the dial 240 bars, the control unit has shut the motor off for our compressor. However, the start button is still on. This is so you could see that the compressor cycle has completed and would acknowledge it by pressing that and disengaging the start button. The thing is that you won't be able to restart that compressor by redialing the pressure unless the start button is depressed, and that is another safety feature for our compressor. Now if we check our meter, we should get about 25.9 hours, and that should mean that it took us about 1 hour and 5 minutes to fill the tank from 0 to 240 bars. So topping it up from 150 bar should take only around 20 minutes. Now, once that start button is released, what we will do, we will close the tank. And we will bleed the hose from the top. Normally we can do it at the filter, but right now we don't want to lose any moisture from inside, so we will be bleeding it from the top. Alright, now I'll try to drain the moisture into the measuring cap without spilling too much. Okay, you can see that the level of moisture in that measuring cup is right on the mark, and I can see that our filter is doing pretty good job. So over here you've got a completely self-contained automatic compressor that would unhook you from your scuba shop and make you fully self-sufficient air gunner at only a fraction of the cost of the small scuba compressor that otherwise you would have to buy. Now, as I promised, I'll also talk about that smaller unit. That unit is based on the same platform as Omega Raptor. The only difference is that we don't like the automation control of Omega Raptor and we don't like their filter, because I reckon that their filter is too small. Also it's filled with silica beads, so it's not an efficient way of filtering moisture, simply because once those silica beads are contaminated with water, they have to be treated, and there's no way of treating those silica beads because it's too hard to open that filter. Also, siphoning the pressure every 25 minutes, I mean that's simply gonna make your overall charging process longer. So I reckon that this whole setup that we've got here is simpler, more elegant and more efficient. The main difference between two units is that the smaller unit has a coaxial piston system. It does require less power, but overall it's less efficient, because this particular one is a 700 watt 0.7 kilowatt or 1 horsepower motor, and it is 4 times as slow as the large one. So 1/3 of the power, but 1/4 of the charging rate. So, but I guess horses for courses, because that unit is much cheaper. Once again, same setup for the control, because we do the control box, and same setup for safety, fuse and rupture disc. But the rupture disc of that unit is proprietary, so you really should be careful not to blow it, because you will have some fun time trying to find a replacement. Okay, that's all for today.